In this video, we will focus on 3 forms of deductive reasoning so that we can start writing proofs using these 3 forms. The first thing we need to know is, well, what is deductive reasoning? So there are 2 types of reasoning that we generally use. The first is called inductive reasoning, and inductive reasoning is when we use a pattern to make a conclusion. So for example, every Monday for the last 3 weeks, a plane has left Logan Airport at 9 a.m. headed for Palm Beach, and we conclude that next Monday the same thing will happen. Similarly, if I see a pattern like 1, 2, 4, 8, I might conclude that the next number is 16 because I notice a pattern of doubling. So that type of reasoning is called inductive reasoning. The second type of reasoning that we commonly use is called deductive reasoning. And deductive reasoning is when we make a conclusion based on what's called logically sound reasoning. So we have some facts and we put those facts together in a certain format to make conclusions. This example says Cheryl gets paid $80 every time she works a full shift at her job. Fact, you know that yesterday she worked a full shift. Fact, you make the conclusion that she has made $80. So the format that you just used is something that we are going to formally describe as direct reasoning. The form of direct reasoning takes the form we just used with Cheryl. It says you have this if-then statement. You know that if Cheryl works a full-time shift, then she gets paid $80. You discover that she worked a full-time shift. You conclude that she made the $80. So this format again is called direct reasoning. And the form works like this. We have 2 given pieces of information, one just a phrase statement and one conditional statement. So we have some statement P. We also have a statement that if P is true, then Q is true. And we can therefore conclude that Q must be true. And in our example, we have if a car is out of gas, P, then the car will not start, Q. We are given the information that the car is out of gas, so we make the conclusion that the car will not start. The second common form of reasoning that we use is called chain reasoning. And chain reasoning allows us to chain reasons together in kind of a domino fashion to make a conclusion that is also in the form of a conditional statement. So we have this format, if P, then Q, if Q, then R, therefore if P, then R. So here's our example. If you get a job, P, then you will earn money, Q. If you earn money, then you will buy a car. Let's call that R. It's a new statement. So then I can conclude that if I do go get a job, then I will be able to buy a car. So one of the things people tend to get confused about is that they're like, well, but what if I don't know that that's true? When we say given, given means given as true. So anything that's listed under given, you should assume is true, and then we make a conclusion based on that given as true information. The third and final form of reasoning that we're going to talk about is called indirect reasoning. And indirect reasoning involves a negation. So here's how it works. I have this given true conditional statement, and then I'm told that the conclusion or the negation of the conclusion is true. Therefore, I can conclude that the negation of the hypotenuse is true. So this one makes much more sense if we give it as an example. If my sister wins the tournament, P, then she will bring home a trophy, Q. My sister does not bring home a trophy. Remember, that's the negation of Q. Therefore, we can conclude she must not have won the tournament. That's the negation of P. So if you recall, yesterday in class, we talked about those Venn diagrams. And often the easiest way to think about indirect reasoning is to think about it in the form of a Venn diagram. So I've set up this Venn diagram to show that if somebody lives in Framingham, then they live in Massachusetts. So let's think about that conditional. I'm just going to write it in a shorthand form of P implies Q. So I'm going to say, if we're in Framingham, then we're in Massachusetts. So that's one of my givens. And the second piece of given information is I'm going to tell you that I live in Framingham. So here I am, Miss Streitman, I live in Framingham. So Miss Streitman lives in Framingham. And from those two pieces of given information, I can see from that diagram that I must then live in Massachusetts. So I'm going to conclude with this therefore. These three little dots like this in a triangle is a symbol for therefore or in conclusion. I'm going to conclude that Miss Streitman lives in Massachusetts. So this is direct reasoning, right? We have P implies Q, P, conclusion, Q. But what if I have a friend and my friend lives outside of Massachusetts? So here's my friend out here. Okay, so I still have this given information that Framingham, if someone lives in Framingham, then they live in Massachusetts. But now I'm given information about this friend, and the friend does not live in Massachusetts. So I can conclude, remember this is a negation here, I can conclude that there's no way that the friend could live in Framingham, because if they did, they would live in Massachusetts. So again, this form is indirect. I have P implies Q, not Q, or the negation of Q is true, therefore the negation of P can be concluded. Some common forms of invalid reasoning that people like to use that we absolutely cannot use in a logical argument are people sometimes mix up the letters. So if you cannot apply a specific logical rule, one of the three that we just talked about, then you cannot make a valid or legitimate conclusion. So if one of those three reasons, direct, indirect, or chain reasoning, doesn't validate your argument, then you cannot make a valid argument. So some common things that people like to try to make conclusions from are things like, if it is raining, then it is cloudy, therefore it is raining. So that's silly, and we can draw a Venn diagram showing that that's not true. I can say, well, if it is raining, then it is cloudy. It is cloudy. Well, it is cloudy means that it could be cloudy and raining, or it could be cloudy and not raining. So we cannot make the conclusion that it must be raining. This is not valid. Sometimes you'll hear people try to give confusing arguments that make you try to connect things that aren't connectable. So here's one example. If Miss Streitman goes to the mall, she'll buy a frozen yogurt. If Mr. Morabito goes to the mall, he will also buy a frozen yogurt. We're both big fans of red mango. So someone might conclude that anyone who goes to the mall will buy a frozen yogurt at Red Mango, but that's using inductive or pattern reasoning. That's definitely not true. I'm sure you can easily find a counterexample of someone who goes to the mall and does not buy frozen yogurt. So that's another type of invalid reasoning. We cannot use arguments like that because we end up making conclusions that aren't correct. So we're going to color code 4 examples to see if they fall into the valid or invalid category. And if they're valid, we want to know which type of reasoning did we use. There's only 3 types of valid reasoning that we've learned, and we will have to use one of those to show that something is valid. So I'm going to color code everything, and then I'm going to label it with P and Q. So let's look at the first one. It says, if today is day 2, then we have F period. We're also given, again given as true, that today is day 2. And someone wants to make the conclusion that we can conclude that we have F period. So let's code this. I'm always going to code it with the P and the Q. P, today is day 2. I see 2 P's. And Q, we have F period. So it looks like the format that this argument uses is P implies Q, or if P then Q. We're also given that P is true. So these are our given true pieces of information, and we want to conclude that therefore, or in conclusion, Q. Is this a valid form of reasoning? Yes, this is direct reasoning. So we say it is valid, and it has the form of a direct argument. In our second example, I'm going to color code the same. Today is day 2. Then we have F period, same conditional as before. Again, we're taking this as true. And then it says we have F period. Conclusion, today is day 2. So let's see what form this one takes. We have P implies Q, or if P then Q. Then we're told Q is true, and this person wants to conclude, therefore, P is true. So this form does not work. Remember, this is P in here. This is Q out here. Well, it could be day 2, but could also be day 4 or day 6, right? This is not a valid form of reasoning. So we can either say we know it's not valid because it's not direct or indirect or chain reasoning. We can also give a counterexample, right? A counterexample is that it could be day 4. On day 4, we have F period as well. So we can't make the conclusion that it must be day 2 just because we have F period. Okay, this one involves more colors. So let's get my colors out. It says today is day 2. If today is day 2, then we have F period just like before. And now it says if we have F period, then we have homework. I'm going to need a new color for that because I haven't seen the have homework yet. So I'm going to use blue. So if today is day 2, then we have F period. If we have F period, then we have homework. And the conclusion, someone wants to say, well then, if today is day 2, then we have homework. Is that a valid conclusion that if it is day 2, then we have homework? Let's write out what that looks like. P implies Q, and Q implies R. Can we make the conclusion that P implies R? Yes, because if we domino this together, the Q matches with the next Q. So we know that if P implies Q and Q implies R, we can conclude that P implies R. This form of reasoning is called chain reasoning. So it is valid, and it is the chain reasoning type of logical argument. And our last one, we're going to continue our color coding. Today is day 2. Then we have F period. And it says we do not have F period today. Remember that not is a negation, right? And someone wants to conclude that then it must not be day 2. So let's see what this looks like in PQ form. So I have if P, then Q, or P implies Q, and then it says not Q. So not Q, we use that squiggly line for the negation. And this person wants to conclude not P. Therefore, not P. Is this a valid form of reasoning? We can always do the Venn diagram as well. If P, then Q is true. Not Q means I'm standing out here. So it is valid to say not P. So valid, and this form of reasoning is called indirect reasoning. So let's recap. A couple things. Number 1, always, always, always color code. If you don't have any colors, you can use different shapes. Shapes will work as well, but you really need to make sure you know what are P, Q, and possibly R, and what format do they take to determine if the argument is valid. So we have deductive reasoning. Deductive takes the form of direct, indirect, or chain. If it doesn't take one of those forms, it is invalid. So the 3 valid forms of deductive reasoning are direct, indirect, and chain reasoning. Anything else is invalid. Inductive reasoning is when we use patterns, and we use patterns all the time to make conclusions, but we cannot use that when we do proofs. Proofs are very specifically a deductive form of reasoning. So inductive is patterns, deductive is logic. So in your practice today, you will look at whether or not reasoning is deductive or inductive, and we'll also look at if different types of arguments are valid based on whether or not they meet one of those three forms of valid reasoning.